First question, Dr. Christina Cartman, nutritionist, claimed that the average number which of calories, so this is a population mean in a serving of popcorn is less than 74. So mean less than 74, this is the claim. And the less than, and so write down H1 alternate hypothesis. For equal, mu equals 74, right, for the null hypothesis H0. So as long as have an equal sign, have greater than or equal, have equal sign, or less than or equal, have equal sign, and that's go for a null hypothesis. If a no equal sign, like not equal, greater than or less than, that's not equal sign, and write for the alternate hypothesis H1. So we write this, that's the first step. State the hypothesis and identify the claim. So we state the null hypothesis is mu equals 74, and the alternate hypothesis H1 is mean less than 74, and indicate the claim. Second, now continue with the standard deviation. It's 8. So standard deviation sigma equal 8. A sample of 49 servings of popcorn, so n equal 49, was found to have an average of 70. So the sample mean 49 serving popcorns, the average calorie is sample mean x bar equals 70. Then check Dr. Cartman's claim at alpha. Claim is less than 74. At alpha is 0.05. Provide the 5-step procedures. So first step, put down H0, H1. Second step, find the critical value. Find the critical value according to alpha. So here, since it is less than this point to the left, less than point to the left. So this alpha is totally alpha equals 0.05, totally to the left tail. This is a left tail test. So on the left tail, alpha equals 0.05. And since it is a symmetry, normal distribution is a symmetry. So this other side also 0.05, the right side also 0.05. And this confidence interval is going to be 1 minus 0.05 times by 2. 0.05 doubled. So it's equal 1 minus 0.10, which is 0.90. So it's a 90% confidence interval. And use a 90% confidence interval in t-distribution. And for the z-score, because population standard deviation is given, equal 8. So you figure out z-score. So here 90% confidence interval in t-distribution table, and 90% confidence interval, and go down to the bottom row and figure out this z-score is 1.645. It's a z-score. So left side is negative 1.645. So this is z alpha equal negative 1.645. This point is positive 1.645. So we just want this side because this is a left tail test. Pointer point to the left is a left tail test. The alpha totally go to the left tail. So this critical value is negative 1.645. Use this 90% confidence interval. Find out. That's the second step. The third step, calculate the test value, test value, test value, and use z-score equal to z-test, sample mean x bar minus population mean over standard deviation divided by square root of n, equal to sample mean is 70 minus population mean is 74 over standard deviation 8 divided by square root of n is 49. So 70 minus 74 is -4 over 8 over 49 take square root is 70. So divided by 8 over 7, reciprocal. So 7 go to numerator, tying together. So this you will get is -4 times 7, -28 divided by 8. You get -3.5. And compare -3.5 with test value is -3.5 compared with the critical value. So -3.5 is less than the critical value, -1.645. So this negative here is to the left of critical value. This test value is -3.5. Is here is to the left of the critical value. So it's falling in this region, and this region we call critical region, rejection region. So this test statistics is falling in the rejection region. So this side is reject, H0. So we got the fourth step is decided whether to reject or not reject H0. So this is a reject H0. So because it's falling in to the left, in this is a reject H0. It's falling in here, in between, in here, and that is a fail to reject H0. So this is a reject H0. And then we write down the wording. How to write the wording? Final conclusions. Summarize the results. The fifth step, summarize the results, is wording the final conclusions. So first of all, I will show you. This is a table. Hypothesis test, a wording of final conclusions. First of all, is original claim contain H0 contain the condition of equality, which is H0. Is like this original claim. Original claim is not H0, is H1. So if not is not, go this way. Go this way. And go this way is not. Original claim is H1, is not H0. If original claim is H0, go this way and get two conclusions. If original claim is not, is H1, H1 go this way, and then look at reject H0. If reject H0, go this way. If not reject H0, go this way. So this, if original claim is H1, then look at reject H0. So yes, go this way. So then you will say the sample data support the claim that original claim. So this is because you reject H0. So this question reject H0. That means support H1. Support H1. So then we will say there is sufficient evidence to support H1. H1 is what? Is Dr. Christina Carterman's claim that the average number of calories in a serving of popcorn is less than 74. So totally 5 steps. First step, find out null hypothesis H0 with equal sign. and find out alternate hypothesis H1 without equal sign and indicate which claim. And the second step, find out critical value according alpha. If a left tail tests, then the alpha totally go left tail. If right tail tests, the alpha totally go right, right tail. If two tail tests, then alpha need to be divided by 2. It's the two area, the two tail add together is alpha. Then figure out this between confidence interval and use the table, find out the critical value, the z-score critical value. Then the third step, find out test value. Now, since this is standard deviation is given, so use z-score formula, z-score formula. Now, then you compare the test value with critical value. If a test value less than critical value, like this, test value less than this critical value, the test value is falling in rejection. This side is a rejection area. In rejection region, that's a reject H0. Reject H0. And then your wording, find the fifth step, write down the final answer. If decided your claim is H1 or H0. If your original claim is H0, go this way. If original claim is H1, go this way. Then since this is H1, original claim is H1, alternate hypothesis, then we go this way. And then ask reject H0 or not. If reject H0, go this way. And then you will say there is sufficient evidence to support claim because reject H0. So that means support your claim H1. So five steps. The next question, it's question 2. At a certain university, the average attendance at a basketball game has been 3,300. So average, that's the mean. So the given is a mean equals 3,300 attendance. And due to the decimal showing of the team this year, the attendance for the first 12 games, n equal 12. 12 games, the average, simple mean average. So x bar is 3,700 with a standard deviation. So that's a simple standard deviation. S equals 680. So this question is given simple standard deviation. Population sigma standard deviation is not given. So this should be used t-test. The athletic director claim, this is the claim that the attendance is greater than last year. So this greater than, so we claim this H1. If greater than, there's no, there's equal is for H0. Greater than or less than or not equal for H1, alternate hypothesis. So then claim is mean greater than 3 last year. Last year is 33300. That's the original claim for H1. And then you write down H0 is mean equals 3300. That's the first step. First step. And since it's greater than, that's point to the right. So this is a right tail test. Right tail test. And check the director's claim at alpha equals 0.01. So alpha equals 0.01. So this 0.01, this alpha totally go to the right, right tail. This is alpha. And since this normal distribution is symmetric, so the other side also 0.01, and you can find out between it this one is 1 minus 0.01 times by 2, because the 2 side. So it's a 1 minus 0.02, and that is 0.98. So it's a 98% confidence interval. So we find out the 98%. And since this is, we are looking for, because S is given, population standard deviation, sigma is not given, so we will use t-test. And use t-test, critical value, we have to look at the degree of freedom. N is 12, minus 1 is degree of freedom, it's 11. So you look at this table, it's a t-distribution table. Degree of freedom is 11, 11, and here say 98%. So 11, 98%, 98% here, 98%. Degree of freedom 11. Intersection is this 2.718. 2.718, 98%. Degree of freedom is 11. So this side, the right side is positive. So positive 2.718. This is T alpha. That should be T alpha. And that is because it's a T alpha. And then this is a critical value. Critical value. That's second step, find critical value. Third step, find the test value. Test value use t-test. So t equals sample mean minus population mean over S sample standard deviation over square root of n. Sample mean is 3,700 minus population mean is 3,300 over sample standard deviation 680 divided by square root of n. N is 12, so square root of 12. So subtraction is 400. 3,700 minus 3,300 is 400 over 680, and divide. So the reciprocal, this square root of 12, multiply on the numerator, and cancel. And cancel, and use calculator, you figure out it's 2.0377. This is a test value. Compare this test value with the critical value. Critical value we find out is 2.718. It's less than critical value. So test value is to the left of critical value. 2.0377 test value is less than 2.718 is less than. So test value is falling in this region. In this region, it's a fail. This is a fail to reject. If falling in this region, if test value is here, that's falling in rejection region. That's reject H0. If falling in here is reject H0. Is falling in this in here, that is a fail to reject. Fail to reject H0. So that's a fourth step. Fail to reject H0. Then fifth step, write down the final conclusions. And the wording of final conclusions. And you look at the original claim is H1. So then we go this way. If original claim is H0, go this way. If original claim is H1, go this way. Now then, if reject H0, go this way. If fail to reject H0, go this way. So this is original is H1, so go this way. Fail to reject H0, go this way. And then so it's fail to reject H0. So that means this sample suppose H0 is not suppose H1. So your wording is there is not sufficient evidence to support the claim. So then we write down the final conclusion. There's not sufficient evidence to support athletic director's claim that the attendance is greater than last year. Then question 3. Scientists claim that only 65%, so this is a proportion problem, P equal 0.65. 65% of geese in his area fly south for the winter. And he takes 60 random geese, so N equals 60 random geese in the summer, and finds that 10 of them do not fly south in winter. And because here is fly south in winter, 65% fly south in winter. So we have to figure out out of 60 geese, how many fly to the winter. Since here is 10 do not fly to the winter, fly south in the winter. So the 60 minus 10 and get 50 fly south to the winter, in the winter. So figure out the probability P hat, sample proportion P hat equal X over N. X is 50 fly south in the winter divided by 60. So the is a 5 out of 6 is the probability fly south in the winter. That's a sample proportion. Now, if alpha equals 0.01, so given alpha is 0.01, is there enough evidence to support the scientist's claim? Scientist's claim is here, claim. The scientists claim that 65% of geese in his area fly south of the winter. So this is the claim. Proportion P equals 0.65. This is the claim. So it's equal sign. So that's given for H0. And the H1 is not equal. P not equal 0.65. Not equal. Now according H1. H1. So if H1 is not equal, it's going to be two-tail test. If H1 is less than, that's left tail test. If H1 is have a sign greater than, that's right tail test. So this is not equal, it's a two-tail test. Two-tail test means this alpha 0.01, you divide it by 2. So left tail is 0.005, right tail is 0.005. The two tail add together total is alpha 0.01. And then, so this area is 1 minus alpha 0.01 and get 0.99. So this is a 99%. So use table, figure out the critical values. Critical value, the two value, critical values. So the 99%, you find out proportion is always use Z score. Use a Z test for the proportion always. So 99% here, 99%, and go down to the last row, go two-tail test. 2.576 is a Z score. So it's the right Z alpha over 2 is 2.576. The left is net 2.576. So that is the two are critical values. Critical values. Now then you figure out the test value. Test value is use the proportion Z test for proportion formula. It's P hat minus P over square root of this one, square root of PQ over N. This one is the standard deviation of proportion. This formula is the standard deviation of proportion. So the P hat is 5 over 6 minus P, 0.65 over square root of. P is 0.65. Q is 1 minus P. 1 minus P. 1 minus 0.65 is 0.35. So Q is 0.35 over N. N is 60. Over N is 60 and take square root. Then you use calculator, figure out 2.97732. And this number is greater than the critical value, 2.576. So it's falling to the right of critical value. So falling in the rejection region, in this, to the right. 2.977 is greater than 2.576. So this test value is falling in the rejection region, also called critical region, in this region, in here. And then we reject. This in rejection region. This is reject H0. If falling between this is fail to reject H0. And if falling in rejection region, critical region is reject H0. Now then, that's the fourth step is say reject H0. Then the fifth step, find the final conclusions. Final conclusion, we look at if in the original claim is H0. For the wording, you go this way. If the original claim is H1, and you go this way. So this is this way. Also separate reject H0 or fail to reject H0. So this is reject H0. Reject H0. Then you will say there is sufficient evidence to warrant rejection of the claim that. So since this is reject H0, so reject this claim. So then you will say there is sufficient evidence to reject the scientist's claim that only 65% of geese in his area fly south for the winter. Just copy this statement, that this claim then. This statement. Copy. The claim is there is sufficient evidence to reject the scientist's claim that only 65% of geese in his area fly south for the winter. Original claim. You copy right down. Then question 4. Question 4. A lab technician is tested for her consistency by making multiple measurements of the cholesterol level in one blood sample. And the target precision is standard deviation. So this is for standard deviation. It's sigma. Standard deviation is 1.4 milligram per deciliter. So the standard deviation equal 1.4. If 14 measurements, so n equal 14, are taken, and the standard deviation, this is sample standard deviation, so we put S, is 1.1 milligram per deciliter, 1.1. Is there enough evidence to support the claim? What's the claim? That her standard deviation is less than the target. The target is the target precision is standard deviation 1.4. Now here want to be less than. So if I have a less than symbol, and let's go for alternate hypothesis, right? For alternate hypothesis. So this is the claim. The claim want the standard deviation is less than. the target. The target, it's 1.4, so it's less than 1.4. So this is indicate this is the claim we want. So the other one, H0 is with equal sign, sigma equal 1.4. So first step, write down H0 and H1 and say at alpha equals 0.025. So alpha equals 0.025. So this is going to be used the chi-square distribution. Chi-square distribution, So we draw this horizontal, vertical, and this is started at 0. And chi-square, square, so it's positive. There's no negative, positive. And want to be less than. Less than means the alpha 0.025 is totally alpha go to the left tail. This left tail 0.025 totally go left tail is 0.025. So then because chi-square is going to use the area to the right of chi-square values. So you are going to use because chi-square table. For chi-square table, the alpha, this area, and you find chi-square. Alpha is here on the top. Those is alpha. Is to the right of chi-square values, and use degree of freedom. Then you can find out chi-square. Those are chi-square values. The entry, the body entry, is chi-square values. And this on the top, it's alpha. It's the area to the right of chi-square. It's alpha. So for this question, since it's a left tail test, this alpha totally 0.025 totally go to the left, 0.025. So this remain this one. This area to the right is 1.0.025, and that is equal to 0.975 to the right. So this figure out this critical value, alpha is here. So to the right is 0.975, and find out this chi-square critical values by this table. And to the right is 0.975. So look at the top, 0.975. Now you have to find out degree of freedom. Since n equal 14, minus 1 is 13. So degree of freedom is 13. 13 is here with 0.975 to the right. So this chi-square is 5.009. So then this critical value, this chi-square is 5.009. That's critical value. Then we find out test value. Test value is a chi-square test for the variance. For variance, so chi-square is equal n-1 is the degree of freedom times variance of sample S squared over the population variance. That's chi-square definition. Is this formula is this. N is 30 minus 1, which is 14 minus 1, which is 13, is degree of freedom times variance is standard deviation 1.1 square. This is variance of sample. And sigma square is variance of population. Sigma is 1.4 square. This is variance of population. And figure out this is chi-square value. Chi-square definition is this formula. So get 8.0255. That is greater than critical value 5.009. So this test value 8.0255 is to the right of 5.009 because greater than 5.009. So it's falling in here. So this is if falling in here, that's reject H0. If test value in here to the left, our critical value is falling in rejection region. That's reject H0. If to the right, our critical value in here, that's fail to. So fourth step, write down fail to reject H0. And then we final conclusions, the fifth steps. Now you look at the original claim is H1. So if H1 wording, if H1 go this way, if original claim has H1 go this way, if original claim have H0, null hypothesis go this way. So now this original claim has the H1, alternate hypothesis, so go this way. And separate into two. One is reject H0, one is fail to reject H0. Since this one is a fail to reject H0, so this question is suppose fail to reject H0. That means suppose H0 is not suppose H1. But this is original claim. So they will say there is not sufficient sample evidence to support the claim that. So we'll say there is not sufficient evidence to support the the lab, write down this lab to support the lab technician claim what? Claim that her standard deviation is less than the target. Target is 1.4 milligram per deciliter. So write down this. There is not sufficient evidence to support the lab technician's claim that her standard deviation is less than the target, 1.4 milligram per deciliter. Let's just copy this claim done. Copy this claim statement done. And the next one is going to be the p-value. Talk about what's the p-value. P-value. Before we talk about question 5, let's look at this chart, p-value. Finding p-value. And you have to look at what kind of test. Is it two-tail test? Two-tail test, then your p-value is two tails. P-value is twice one tail. If a two-tail test, then you got one tail, you double it. If a left tail test, then p-value is total left tail. If right tail is total right tail, one tail. Only if a one tail test, left tail or right tail, one tail test, the p-value just one tail. The p-value is the area to the left of the test value. And the right tail is p-value is the area to the right of the test value. If a two-tail means not equal is two-tail, and left tail have in H1 have this sign. Right tail in H1 have this symbol, greater than symbol. Then if a two-tail test, then you figure out one tail and double it. P-value is twice the area of one tail test, one tail. So, and this question using the chi-square table, find the p-value interval for p-value interval. It's in for the test value chi-square. This is a test value chi-square equal to 2.043. N equal 11 is a two-tail test. This is a two-tail. Degree of freedom is n-1. 11 minus 1 is 10. And given test value chi-square is 2.043. Now you look at the table and you will see 2.043 with degree of freedom is 10 is falling on the chi-square table is falling between what's two number. Degree of freedom is 10. So here degree of freedom is 10. This. And the 2.043 degree of freedom is 10. And then 2 is falling between the two number. Degree freedom is 10, falling between 20.483 and 23.209. So falling between 20.483 and 23.209. And then for 20.43, for chi-square right, 20.483 degree of freedom is 10. For this chi-square value to the right, this area is what? I see this degree of freedom is 10, and 20.483 to the right is 0.025. So this area is 0.025. That's the chi-square is 20.483. Degree of freedom is 10, is this area. It's 0.025. For 23, if a chi-square equal 23.209, to the right, the area is what? Degree of freedom is 10. And the 23.209 to the right, the area is 0.01. So this area is 0.01. Now, since this test value is between 20.483 and 23.209, so therefore, to the right of this test value is also between 0.01 and 0.025. To the right of this, because to the right of 23.209 is 0.01. To the right of 20.483 is area is 0.025. And test value is between the two values. So to the right of test value, one tail area to the right of test value is also between 0.01 and 0.025, between the two values. Now, this is a two-tail test, and this is one tail. Then you have to double two-tail area, because two-tail test. So you two-tail area, the other tail, you double. 0.01 times 2 is 0.02. 0.025 times 2 is 0.05. So two tail area, which is a p-value, which is just p-value. The p-value, if the two tail is one, you find out one tail area, double it. That's a p-value for two-tail test. So the p-value is between 0.02 to 0.05.